Hey guys, so this video is going to tell you everything you need to know about machine learning. So this is just the index. I'm going to put some annotations here so that you can click to that part of the video, or you could just go along with me. Basic info. Machine learning is a subfield of computer science and is related to artificial intelligence. It is actually one of the methods that is used to program AI. It is an evolution from the studies of pattern recognition, data mining, and statistics. Machine learning is more closely related to the previous studies rather than artificial intelligence. Machine learning was first coined in 1956 by Arthur Samuel. He quotes that it is the field of study that gives computers the ability to learn without being explicitly programmed. What machine learning basically does is that it builds algorithms to predict and learn based on given input data. Algorithms build a model using the given training data. Models are basically algorithms, but they contain all the mathematical terms in them, and training data or training set is the input machine learning gets so it can analyze and learn from it. Types of tasks. So there are mainly three different types of tasks that machine learning uses and does. Number one is supervised machine learning. This is when the program is given an example input and the desired output, and its goal is to learn the basic formula that maps out the output. An example of this would be face recognition. The input would be given such as like the structure or the color of the face, and this data would be used to program how to find a face in a picture. The second one is unsupervised machine learning. This is when the program is not given any specific inputs with labels. The program's goal is to find patterns to create outputs. An example of this would be to group food items into fruits or vegetables based on the given data. The data would not give any labels as to what the data means, and the program has to cluster stuff based on the pattern it finds. Unsupervised learning is mostly used for clustering and putting items into groups. The last type is reinforcement learning. This is when the computer is working with a dynamic environment and has a specific input and output. The program doesn't know when it is done with its work, but the environment tells it if it's doing the right or the wrong thing. An example would be when we are playing games against the computer. Another example is a self-driving car. Both examples have dynamic environments and are given input from the environment. So, some modern day examples. Netflix uses unsupervised learning to determine recommendations for its users. The same applies for search results in search engines. Google Car uses reinforcement learning to drive without any human interaction. Fraud detection sees our credit card history and where it's usually used. And using supervised learning, it determines if a fraud is made when it's suddenly used in a very far away place. These are just a few of the examples that machine learning is in modern life, but obviously there are many more. So, why machine learning now? Machine learning has become such a big thing now, and it is also very popular. Well, this is because in the past century, data collection has increased exponentially, and we now have billions of data that we need to sort or analyze. Machine learning is a type of program that does that. It can also be reused with different types of data and is very versatile. It is also very obvious that it is cheaper and more efficient at doing its work compared to human beings. It is also a large part that contributes to artificial intelligence, as that is a big part of science right now and will be in the future. So, how to make machine learning code? Making machine learning program isn't really that hard. Our ultimate goal in making machine learning is to make a specific classifier for the different type of task. Classifier is just another name for the algorithm that uses the input to create the desired output. So step one of the process is to collect the training data. Training data is just the example of the data or the scenario that the computer will use to train and learn from. This is different for different types of programs or problems. For example, if we show the computer a picture of two animals and tell it to differentiate between a dog and a cat, we would give training data as to the different features of dogs and the different features of cats so that the computer could see the difference and tell which one is which. This is supervised learning. And another example would be if we want the computer to play against us in a game it has never seen before. So we would show it some previous games as training data and let it see what are some of the good moves and what are not. This is reinforcement learning. The training data can vary based on the task that needs to be accomplished. There is also another type of data called testing data. This is used to check if the computer is doing the right thing or not. Basically, it's the confirmer. Over here, we have a table that shows the table for the it shows the table, and these are all the features over here and the labels, and these are the examples. These are the training data that the code would use to determine if it's a cat or a dog. Step 2 is to create an actual classifier using the inputs we gathered. Let's take the example of the differentiating between the dog and cat again. We will do this problem using a decision tree algorithm. A decision tree is basically a set of rules which tells if it's true or false. One rule we might ask the computer would be what is the weight of the animal, or if it's less than 10 pounds. The next rule might be if it meows or barks. Using the process, we can determine if it is a cat or a dog. So over here is the picture of a decision tree, and these are the rules so the computer would see this. This is just the pictorial form, but this is basically what the computer is going to do. It's going to ask if this is yes or no. If it's no, then it's going to go over here, and then it's going to ask yes or no over here as well. The last step is to check if it works or not. If we tell the computer that we have an animal that is 15 pounds and barks, so based on the table over here, we can see that this would be a dog. And when the computer processes this is what the result should be. If it is wrong, then go see what the mistake might be and fix it. The cats and the dogs example is not the best one for machine learning, and machine learning is generally not used for such tasks, but I just used this example to explain the process. The code you see over here is a code I made, and it's basically a simple machine learning program which differentiates between an apple or an orange. So these are the steps to create a simple machine learning program. AlphaGo. AlphaGo is one of the best machine learning programs that exist today. It is the product of Google DeepMind. In October 2015, it became the first computer Go program to beat a professional human at the game. Go is a complicated Chinese game that can't be predicted. So this is the board of the game. Go is unlike chess, this game has almost infinite possibilities, hence predicting the outcome in advance is out of the question, and it isn't the ultimate goal either. It beat Lee Sedol in a 5-match game. It uses artificial neural network, which is a concept in deep learning. The creators are now using the same program to build artificial intelligence that can be used in the medical field. Algorithms. The main part of machine learning is the algorithm or the classifier. That is the code that enables the computer to learn. There are thousands of different types of algorithms for machine learning. That is an extensive topic, and I will create another video for this the following week. So thank you for watching, and please leave your opinion and other information you would like to share down in the comments below. For information about algorithms, watch my video next week. Thank you. And here's the bibliography and the pictures I used. Thanks.